at t equals 5. At that moment, the pile of gravel is decreasing or getting smaller. The amount of gravel is decreasing because it's being processed faster than it's arriving. Okay, I think that's pretty clear. Okay, finally part D, which is I think much more difficult and is of more of a sort of theoretical nature. Part D says, and it's probably like half the points of the problem, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. So notice that we need to not only determine when the gravel is a maximum, but also to justify why it is. Okay, so for this reason, I think what makes this problem hard is that you have to sort of be bold enough and have enough confidence in yourself to like introduce new variables and new notation. I think you almost have to do that. What they're asking for is the when during the time interval 0,8 is the amount of gravel at a maximum. Well, we don't even have a function which represents the amount of gravel. So let's do that. Let f of t represent, so you can invent your own function, and this is what I recommend in situations like this, represent the amount of gravel. The amount of gravel at time t. Okay, now that I have named this quantity, which represents the amount of gravel, now I can recognize that this problem is essentially just saying, hey, when is the amount of gravel maximum? In other words, what we now just need to do is to maximize f on the interval 0,8. Alright, and if that's the case, then I have a lot of experience maximizing functions. This goes back to the previous unit. If you want to find the maximum of a function on a given interval, you should check the endpoints and also compare it to any relative maxima. Okay, good. So right away, perhaps we should just compute the endpoints. In other words, what is f of 0? How much gravel is there at the beginning of the day? Well, that was a piece of information that was given to us at the very beginning of the problem, that the day starts with 500 tons of gravel. Okay, so f of 0 is 500. And what is f of 8, say at the end of the day? Well, this is a little complicated because now we start with 500 tons of gravel, but then the gravel is arriving, and so as we already have seen, the integral of the amount of gravel which has arrived would tell us this is the total amount of gravel which has arrived. I can actually kind of do this one, I suppose, right now, right? Because how much gravel is there at the end of the day? Well, it's going to be how much gravel there was at the beginning of the day, plus how much gravel arrived, so that's this 825.551, but then minus the total amount of gravel which has been processed, and if the gravel is being processed at 100 tons per day, then in fact, 100 tons per hour, and the plant is running for 8 hours, then the plant is going to be processing 800 tons of gravel. And so the answer is that at the end of the day, I'm going to have 525.551. Okay, but what is the, what about the relative maximum, if there is one? Okay, well, here, there are a couple different ways to do this, I suppose. But in order to find the relative maximum, we have to figure out when does the amount of gravel sort of stop increasing and start decreasing or something like that. Okay, but this is sort of hard to do, I think. That, well, I'll just say it. I think the simplest way to do this problem is to write an expression for the amount of gravel at any given time. And this is why this whole concept of integral functions is not as maybe ridiculous as you might think. Because if I want to write an expression for the amount of gravel at any given time, then, well, what's it going to be? It's going to be 500 plus the change in the amount of gravel from time 0 to time t. And how much does the gravel change? Well, if I want to know the change in the gravel, I just have to now compute the integral of the rate at which the gravel is changing. And at any given moment, there are sort of two things happening. There is G represents the rate at which gravel is arriving, and 100 represents the rate at which the gravel is being processed. And so at any given moment, if you subtract the rate at which it's arriving minus the rate at which it's being processed, you get a number, possibly negative, possibly positive, which tells you the rate of change of the amount of gravel. It says the amount which has arrived up to time t minus the amount which has been processed up to time t. And if this is the rate of change, then the integral of that rate of change is the change. Okay, so good. Now it's sort of more clear how to, oh, and of course if you plug in 8 here, then you're going to get exactly what we got, right? 500 plus, the integral from 0 to 8 will be that number, boom, minus the integral from 0 to 8 of 100 will be minus 800. Okay, so finally, now I can be like, okay, I know what to do. I want to find where f has a relative maximum. Where does f have a relative maximum? Well, f has a relative maximum when the derivative changes from positive to negative. And so, what we want to know is, what is f prime, the derivative of the amount of gravel at the plant at a given time? And now we just use the fundamental theorem of calculus. The derivative of 500 is 0, and the derivative of f is g of t minus 100, because the derivative of the integral of something is that thing. Okay, it was also possible to just go straight to this and to skip this step where I created an integral function and then differentiated it. But I think this is sort of worth doing. In this case, maybe not, but in general, this is nice. So what I now have is an expression which represents the rate of change of the amount of gravel. And I'm looking for relative maxima, so now I can say f has a relative max when f prime changes sign from positive to negative. Positive to negative. And so now I need to see when, if ever, this function changes sign from positive to negative. And okay, to avoid having to swing sort of back and forth, I am now going to oh man, I'm so sad. Okay, I guess I just have to keep flipping back and forth. This sucks. So let's do it. All right. And yeah, those are pandas playing chess on a mural. It was for my daughter, I swear. Okay, back on the computer screen. Hopefully this is like working and stuff. Here we go. Yeah, I want to look at a picture of g of t minus 100. And so we can just do this, right? Create a new function, call it, okay, well, unfortunately, I don't want to call it f prime. Maybe I'll just call it like f2 or something. Oops. So what is the f, let's see if it'll let me do that. What is the f2 function? It's the function g, and it's just so nice how you can just do this, right? Just with your computer, g of t minus 100. And so, all right, this almost looks the same, and maybe I don't want to look at this integral anymore, so maybe I click this button to toggle off to get that out of the way. So what happened to this function? What happened to this function is it just got moved down 100. Perhaps you don't like that. Perhaps, yeah, actually, I take this back. Sorry. Let's not do this. You could do that and see when it's 0, but maybe it's more beautiful or something. This was the whole screen. Maybe it's more beautiful or something to just type a new function 100. I called that function h. So h of t equals 100. Okay. So now we have a visual representation of what's going on. what's going on here is the green, and I think I can change this color. Maybe you want it to be something more exciting like red. Okay. So what we have is this green function, which is the rate at which the gravel is arriving, and we have this red function, which is the rate at that it is being processed. And okay, just common sense, here it's arriving at a rate faster than 100. So what's happening here is that the gravel is building up during the first half of the day, and because it's arriving at a rate much faster than it's being processed. But then during the second half of the day, it's arriving slower than it's being processed. And so I can just tell you right now that the absolute maximum is going to be at this point. That is going to be the moment at which the pile of gravel is highest, because from all the way up until that point, more gravel was arriving than was being processed, so the pile kind of just kept growing. Okay, how do we use technology to find that point? Here's why I think GeoGebra is kind of just great and superior to Desmos, on which I can't figure out how to do this. If you click on this geometry button, and then you click on point, then you can go over here and you can just click, boom, and it will label the point of intersection of these two curves. And it's doing that perfectly using technology. That point is now defined to be the intersection of those two curves. I think you can also click intersect maybe, and then click on the two things. Let's see if that works. Maybe people prefer that. Intersect command, and then you just click curve and line, and it does the same thing back in. Okay, so then let's go back to the calculator thing. And now what we have is this point of intersection. Note that our calculator has numerically calculated the intersection of these two curves, and it even defines A as the intersection of G and H. It's quite beautiful. And it's giving you, more decimal places than you could possibly want for that point of intersection. Okay, so the first thing you would now write on your paper is okay, well, they want you to just basically do this with technology, and so the answer is, the phrase is sort of by inspection, which is another way of saying I looked at the graph on my device, the rate of change of the amount of gravel, this thing we call f prime, changes sign from positive to negative at 4.923. Okay, and if you don't like this view of things, okay, now I'm sort of being a little bit ridiculous, but suppose you didn't like this, everything we just did for some kind of reason. You could then do the thing I was starting to do before, which is to create a new function. I called it f2 of t, defined to be g minus 100. This is what I was doing before, g minus 100. If you prefer this way of thinking, okay, great. Why didn't that work? f2 equals g minus 100, enter. And now, somehow that didn't work. Maybe it didn't like this f2 somehow. Why would that be? Okay, something has gone horribly awry, but I cannot figure out what it is. G of t minus 100, but it didn't seem to do what I thought it was gonna do. Oh, yes it did. I just am too stupid to realize that the function is down here now. Okay, so yeah, I have to change my window because now, so settings, so now I'm gonna go I don't know, negative 50 to 150 or something, enter. And so now, perhaps you prefer this better because this f2 function, which is the thing on our paper, I called it f prime, is in fact the difference between the rate at which the gravel is arriving and the rate at which it's being processed. And so here we really are looking at the derivative. And so now you want to sort of see when the derivative is 0, and answer, it's at that same point where the derivative changes sign from positive to negative. So that's your justification for why there is a relative maximum there. Okay, and I guess, well, I'm just going to go back to using the same point. Well, alright, if I'm being like very honest with myself, I guess I should now like type like y equals 0 or something. I mean, this is a little bit silly. Okay, y of t equals 0, and now I want to find the intersection between these two curves, and I think it just did it for me already, but I'll go back here and I'll just click, intersect, boom. Or maybe I need to actually do this. Okay, and so I get the intersection. La 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 la, y-axis and, okay, well you can even just type the x-axis and maybe I didn't even need to do this stupid y thing. Let's just delete that and maybe just we go here and I think it will let you just treat the x-axis as like a thing that you want to intersect with because it's already a line that like exists. So boom, you get B. Okay. So what is B? B is the intersection of this f2 function and the x-axis. It's the point where the derivative changes from positive to negative. Of course, it's that exact same number that we got from over there. So whichever way you prefer to think about it, whether you prefer to construct the difference and find out where it changes sign from positive to negative, or whether you want to just look at where they intersect, either way you get this point, 4.923. And what is this point, 4.923? It's the place where the gravel has a relative maximum. Okay, so the final part of this question says, what is the maximum amount of gravel? And so the maximum amount of gravel, well, you just plug 4.923 into our f function. In other words, what I now would like to compute is 500 plus the integral of, well, for the function, I'm going to basically be integrating f prime. So f2, and I want to start at 0, and I want to end at, if I want to know the amount of gravel that occurs at this peak time, then I want to integrate from 0 up into that peak time. And to reduce any kind of rounding error or whatever, we want to use the exact value. And so what you type now is x, I hope this is right, of a. Is that right? Yeah, boom. Okay, so what this is saying is, dude, give me the start at 500, because that's how much gravel was there at the beginning of the day, and integrate the rate of change of the gravel from 0 to the x coordinate of the point of intersection, or I could have used b because it's the same thing. And this will give me, sort of, to all the decimal places, the amount of gravel that there was at that time. And as we've now seen, that's of course the answer to this problem. Okay, good. Erring on the side of thorough. This is just, I'm just making a mockery of myself here because this video is so ridiculously long and this is supposed to be a 15-minute problem. And I am so sad, but still, here we are, finishing this problem off. We just now write down all the things that we noticed over there on the screen. And I'm sort of teaching you how to do this, so maybe this is justified. And the thing that we're going to now say is that by inspection, which is just another way of saying, dude, I looked at it, f prime changes sign from positive to negative at t equals 4.923. So f has a relative max at t equals 4.923. And finally, common sense says that relative max is going to be the absolute max, but the simplest thing to do is to just compute it in any way you have to. So what is f of 4.923? notice that when I write it on my paper, I round to 3 decimal places, but when I used technology, I was using the stored value up to all the decimal places that were there on the calculator. This is going to be, well, it's the thing I just said. It's 500 plus the integral from 0 to 4.923 of g of t minus 100 dt. And that we just determined, also using technology, is 635.376 tons. And okay, I ran out of space, so that is the absolute maximum. It's the absolute maximum because it's the largest of the 3 numbers that I got out of this process, right? At the beginning of the day, there were 500 tons. At the end of the day, there were slightly more than we started with, but the most amount of gravel ever during that day was the amount of gravel at time t equals 4.923. And that's what they want you to find, right? The maximum amount. So the y value, and we've fully justified it because we know that the maximum must occur at either an endpoint or at a relative maximum. We checked both endpoints. We found the relative maximum using the first derivative test, and everything is all good. Okay, hopefully you get it, and hopefully you have learned GeoGebra, so that's like an important life skill, and also you've learned how to sort of understand, interpret, reason through these problems. This is an example of how much writing you have to do for these problems, and how to use the technology. And I recommend that you also, if you want to be awesome, to download the GeoGebra app, GeoGebra Graphing Calculator app on your phone. And you can do this in every single thing that we just did. You can also do on your phone. I think it's a little bit more annoying because you can't type quite so freely, but it's the exact same sequence of commands. And had we been at school this year, I was going to finally kick the TI-84s to the curb, and I was going to make everyone download this app and do it. And hopefully by next year you can use it on the AP exam. Good. And then the next time you lose your TI-84 calculator, or it breaks, or you even run out of batteries, you should just throw it in the garbage. Or sell it online or something. Okay, goodbye. You have 3 more of these problems to do. Good luck.